You'll use either Excel or, I mean, you could use, I guess you could use a table in theory, right?
Yeah.
Yeah, so one of those two, you would have to use that, right? Because they're all like, stuff having to do with the normal distribution.
Hmm.
Such you can't, you can't really do the integration to pull it off, right?
Yeah.
You just have to resort to using a table or Excel. And incidentally, that's something that you'll be able to do even on the final.
Okay. Cool. Thank you.
Yep. What else? Other questions?
I was wondering what the final would look like. I don't know if you've mentioned it in previous Q&As, but like how the final will work.
Well, I mean, I don't really anticipate it being all that different from what happened with the last exam, where, I'll just send it out probably like on Wednesday or something like that. And then I'll just give you a week to work on it. I'm going to construct it in such a way that I don't necessarily anticipate that it would take you more than like a couple of hours to finish. But hopefully, having that block of time to work on it will give you the flexibility to, um, you know, not have such a time crunch, not necessarily be, bumping up against other classes and whatnot. But I mean, you'll be able to use any course related materials, be it slides or video lectures, notes, book, whatever, right? So homework quizzes, tables, Excel, Wolfram Alpha. I think any of that, I'm going to write it in such a way that those things would be fair game. Does that help, Summer?
Yeah.
Okay. All right. What else? I don't know. I mean, because I'm going to be sending out the final pretty soon, I don't really know that it would be worthwhile for me to uh, have another homework quiz because, pretty quickly you're going to just be working on that anyways. There are going to be some problems related to confidence intervals, but there are plenty of examples that I've done from the slides and lecture where I've done specific examples related to those. So hopefully that'll be enough to kind of train you up in doing those sorts of problems. But those problems are certainly going to be fair game and expected material to be tested over on the final exam. I'll probably post a homework set this afternoon from like chapters 7 and 8, just so you can kind of look in there and practice a little bit, but I'm not going to collect anything from that. The only thing I'm going to hold you responsible for are the things that will appear on the take-home final. Hopefully that makes sense. Well, any other questions?
Can you explain on the last lecture for like example 7, we didn't fully like complete it. Was there extra data that's needed? Like the alpha value, you saying?
Okay, so which lecture? Was that today's lecture?
Yeah, today's lecture.
Example 7. Let me see here. I'll look it up here. Okay, let's see. I'll share this. Which one? Was it this one?
Yeah, that one.
That one?
Mhm.
Yeah, there just wasn't, I mean, estimate a true average strain in a way that conveys information about precision and reliability. And what I did is I just said, well, look, I have the mean, namely 25. I have the standard deviation for the sample, which is 3.5. The sample size is only 15. So which distribution would I use, Ryan? Would I use the normal or the T?
T, because it's 15.
Yeah, right. I would use the T distribution to be on the safe side. So it would be T distribution with, 14 degrees of freedom. But one thing that is not given to me is a confidence level. Does that make sense? So they don't say, with some particular level of confidence. So, I mean, I guess we could like do this. Here, let me get in here and we could do this real quick. There we go. Okay, so I just wanted to annotate on here. So let's see here. So suppose I wanted like 95% confidence or something. I wanted a 95% confidence interval. Okay. Well, what would be the T I would use then? I would need T sub. Okay, so first of all, what do I want? I want to actually have a 95% confidence. I want it to be symmetric. I want it to be a symmetric confidence interval. So my alpha here would be 0.05, right? And so I would do T sub 0.025, 14. Okay, so what I'm thinking about here is this. Right, so here's T sub 14. And I want these like little cutoffs right here. So this is T sub 0.025, 14, which means I have 2.5% here. Right, and then I would have 2.5% down here as well. So this is negative T sub 0.025, 14. Okay. This is 0.025 down here. How can I get this like little T value thing? How can I get it? Well, here, let me change what I'm sharing here and go to, let me just go to my screen so that I can then go in here. Okay, I have 14 degrees of freedom. And if I want 2.5% in each tail, that means that there's going to be 95% or 97.5% below this thing. So look, I get this as my cutoff point, 2.145. Okay. So if I do that, 2.145. Okay. So T sub 0.025, 14. 2 point, what was it again? So, can someone help me out? 2 point what? 2.145. Okay, and then to get the confidence interval, all I would do is I would go X bar minus this thing, 2.145, times the standard deviation, which is this, right? That's S. This is X bar right here. Times the standard deviation, which is S, divided by the square root of 15. And then I would go X bar plus 2.145 times S over the square root of 15. And that would be the 95% confidence interval. Does that make sense, Ryan?
Yeah, so you just have to choose like a confidence interval that's pretty high. Is that?
Yeah, I mean, that's it. It just estimate the true average strain in a way that conveys information about precision and reliability. I didn't choose I mean, in the lecture, I said we would just have to know a specific alpha level. Here, I actually gave one. I just said, okay, well, I want to be 95% confident that the random interval that we get back is going to contain the population mean. And so here I decided 95%, but I could have done a higher one, like, 99%, or I could have done a lower confidence interval, confidence level. I could have done like 90% or something. I just have to specify one. And by the way, what do you think is going to happen to the interval if I like increase my confidence level? What do you think is going to happen to the interval? If I increase
Get bigger,
confidence level, what do you think is going to happen? Do you think it's going to get smaller or wider?
wider.
Wider, because I need to be more sure that it's going to contain the population mean. Yeah. If I want
If
to
you
shrunk down confidence interval, I'm going to have to shrink my confidence level also. I'm less confident that it contains the population mean.
is it true if that it goes to like 100%? Would it be infinitely wide?
Yeah. Because there's always going to be some small level of uncertainty, always, no matter how big the thing gets. It's like it always could have been due to like some wild chance that I have this huge interval and yet the population mean is still outside of it. I just happen to get a really bad unrepresentative sample. Does that make sense, Ryan?
Yeah.
Right. Okay. What else? Other questions? Other questions? So again, when I use that table, I'm just going to draw this picture real quick. Here's 0. Here's the t distribution with 14 degrees of freedom. Here's 2.145. What I know is that to the left of this is 97.5%. 97.5%. Okay, so that's how I was using that table. Is I said, well, how much probability is in the one tail? Well, 97.5%. Okay. All right. Hopefully the way the tables work makes sense, and Excel operates in a similar fashion. Any other questions? Any other questions? Okay, I'm probably going to spend 1 or 2 lectures just doing some basic stuff with hypothesis testing. But really, the essence of hypothesis testing is right here. It has to do with confidence intervals. Every single hypothesis test we do can be converted to a confidence interval problem. That's the essence of what's going on. But it's just another way of recasting the confidence interval concept so that we can use statistics to say things with a certain degree of certainty. So that's what I'll be doing on the last couple of lectures here. Okay, so again, I'm going to post some problems for you to kind of work on in chapter 7 and 8 of Lalowski-Dean. But I'm not going to collect anything. I'm not going to make you turn any of that stuff in. I'm only going to hold you responsible for that on the take-home final. Okay? All right. Well, if there's nothing else, I say keep doing your thing. Go work on whatever it was you were working on, and have a great afternoon, everyone. All right?
Thank you.
Yep. See ya.